Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. Okay, moving on to outcome 4. Now, as explained in the previous video, there's a bit of mix-up with City and Guild's qualification handbook and assessor information. So I'm following the assessor information, which basically calls the understanding fundamental principles for the design and installation of associated protective systems relating to electrical installations as outcome 4. So that's what we'll stick to. In the handbook, you'll see it's something else. This, according to the assessment criteria, it's only in the assignments, it's not in the written exam, and it's one question. To understand the fundamental principles for the design and installation of associated protective systems relating to electrical installations. So the associated systems. So this is obviously recognising that whilst we'll have our initial design, which will be, my demand for power and my utilisation of power is this, there'll be other systems that will either be part of your electrical design or you'll have to work alongside them. Okay, and it does, in the actual qualification handbook, give you a, this is just explaining confusion here, it does give you a list of these systems in the handbook, and here they are. Okay, suggestive. There are others, but this is just a suggestive list, and we wouldn't go into this full depth. We can only really need to use a few of them. But what it's suggesting is, okay, you're going to do an electrical design, you're going to do your lighting, your power, but we need to remember other things that are supplemented by BS 7671, or maybe not even in the scope. Yet our design may need to accommodate, or to compensate, or to incorporate them. So we have lighting protection systems. We have methods of protection against corrosion and erosion. Fire systems. Lighting systems. Remember, what the client wants for lighting isn't necessarily what the client must have for lighting. If the client is going to put people at work in a building, there are legislative requirements to have a safe work environment, and they'll be pushing other standards than BS 7671. Such as BS 5266, which will give you requirements of light levels for escape and fire, etc., etc. Then you have to think about other supplies. You may have an alternative supply, such as photovoltaic. You may have a UPS system, and there may be segregation requirements between those. So, just to highlight a couple. Lightning protection systems. Regulation 411.3.1.2, protective vehicle potential bonding, does say connection of a lighting protection system should be in accordance with BSEN 62305. Now, it's not up to you to know BSEN 62305 unless you actually, put scope onto this type of work, and you need to develop that level of technical knowledge. But what is required is for you to recognise that lighting protection systems may be present on the building or structure or adjacent to the structure that you're working on, and you may need to incorporate that with your design. With regards to lighting protection zones, similarly, we don't need to know about them from a BS 7671 perspective. We need to know how to work with them. With regards to corrosion and erosion, we can go to Appendix 5, Corrosive and Polluting Substances, AF, and it tells us to go to BSCN 60721. Okay. There is, coming into the 18th edition, currently a mention of galvanic separation, 730.313.1.102. That may change. We'll see what happens. Which suggests the potential of circulating currents creating some kind of corrosion on vehicles on offshore narrow boats and things like that. So there was a mention of corrosion there. Fire protection, we would go to BS 5839, but we need to understand from a wine regulations perspective, we do need to remember that there is in Part 5 safety services, and it will say, segregation. We need to make sure that a wiring system is installed that is separated from the mains power. Same with emergency lighting. So we need to wire them in a route that is direct, that is deliberate, that is not on a a deviation path to accommodate other lighting and power demands. The wiring system erected for fire and the wiring system erected for emergency lighting should be direct and should be, fire propagating to actually, work. But all this technical requirement is in BS 5839, which if you do dabble into fire alarms, being manual or automatic, you should have familiarity and training within. Similarly with lighting systems. With lighting systems we have standby lighting systems, we have self-contained emergency lighting systems, we have centrally supplied emergency lighting systems. If it's a centrally supplied emergency lighting system with one central system, then we need to consider the monitoring of that system. We need to consider the wiring system that is actually then wired back to the lighting. Is that that will need to be fire retardant to some degree, because it needs to actually work in a fire condition. Whilst if the luminaires were self-contained, then that's fine, because the source of energy is therein, it's within the luminaire. So there are benefits of one system compared to another. Okay, but you need to remember this isn't in BS 7671, this is in BS 5266 and beyond. But you need to know that when you do a design, you need to incorporate these requirements. Similarly with alternative supplies, UPS supplies, UPS standby supplies for IT, medical locations, or solar photovoltaics. Now if you've got solar photovoltaics, you've got a supply source that if you turn the main isolator off, if the photons are out, if the solar radiation is there, you're still going to have a presence of source coming through to the inverter. So there'll be another isolator on the supply side of on the AC side of the inverter, or you'll have a big label on the fuse board that will say 2 sources of supply. These are the other characteristics you need to be aware of. Similarly, you'll have DC cabling coming in, which will be energized. So you may need to label that up if it is in some risk of impact, should someone turn it off and then think that that equipment is dead. So we've got to consider other services, other systems with regards to our design. Now, we may get a specialist contractor to come and help us with that. That doesn't mean it's not up to us as designers to recognize that these protective systems exist.